Hello, I am Tyler Linder, and this is my Lab 1 report on charged tapes for Physics 2212 in summer 2021. So here, this lab is about calculating the electric charges on common household objects, and the goal for this lab is to be able to find the excess electric charge on a piece of clear tape. The fundamental physical properties of this lab is Coulomb's law, which includes electric fields and forces and point charges. And here are the results from this lab. In order to do the experiment, you must have two pieces of clear tape. First, create a base tape and a U-tape. Place those together with sticky side on table and U-tape on top of base tape. Then quickly remove U-tape from base tape. Step 2 is to check if the tape is negatively charged by charging a plastic pen and observing the interactions between the two objects. You can easily charge the plastic pen by rubbing it on a piece of cloth or hair. Step 3 is to repeat the previous two steps 2 more times for the tape. Step 4, hover over one of the tapes until the free parts of the tape floats. After that, record the distance between the tapes while it is floating. After experimenting, I observed that both tapes repel because they have like charges of a positive charge. The top tape floats at a distance of 0.022 meters when the other tape moves towards it. The electric force due to the bottom of the tape opposes gravity. After the experiment, I assumed that the tapes model point charges and they have the same net electric charge. Here are the measurements of data from the tape that I used. The tape was a length of 0.2 meters and a width of 0.02 meters. The tape weighs about 2 times 10 to the negative 3 newtons, and it has a surface area of 4 thousandths meters squared. The number of atoms are 4 times 10 to the 17th power. This computational model was created on GlowScript. Here are the lines for my constants and calculations in order to get our results for this lab. My constants include the Coulomb constant, the tape's length, the tape's mass per meter, the distance between the two tapes when brought together, the atom length, the tape width, electron charge, and gravity. My calculations solve for tape mass, the force of gravity, the tape's charge, the surface area, the number of atoms, the number of excess electrons, and the ratio between the number of atoms and number of electrons. When the constants are substituted into the equations, we are able to find our number of atoms, our number of electrons, and our ratio between atoms and electrons, and the charges of the tape. Towards the left is a visual representation of our computational model. The top green arrow, pointing in the positive y direction, is our electric force on the top piece of tape by the bottom piece of tape. The red arrow pointing in the negative y direction is our force of gravity for the top piece of tape. The green arrow pointing in the negative y direction is our electric force on the bottom piece of tape by the top piece of tape. Once the code runs in GlowScript, we are able to print out our calculation results. We get the tape's mass, gravitational force, surface area, the number of atoms on the surface, the number of excess electrons on the surface, the charge of each tape, being that they are both the same, and the excess electrons to atoms ratio on the surface. So, what if the electrons are negatively charged and protons are positively charged? what if the signs of their charges were reversed? Meaning, if the electrons were positive and protons were negative. What would change about the observations you made with your tapes and other charged objects? In this case, nothing will change about the observation because each piece of tape will have the same charge. So, the tapes will still repel. Why is it important to handle the charged tapes as little as possible when doing this experiment? Why is that? What happens when the charged tapes come into contact with your hands or other objects? In this case, the electrons will travel to whichever object it is being interacted with. They move towards the more neutral objects, to be specific.